Good day, everyone. Our project is called Fluffy. Fluffy is a single-player educational memory match game developed using Java. The game challenges players to match a pair of cards while improving memory, focus, and pattern recognition skills. Next, for our project's purpose and features. The main purpose of Fluffy is to provide a fun and interactive way to train memory skills using a visually appealing game interface. Key features includes multiple levels with increasing difficulty, timer and scoring system, animated card flipping, pause menu and level selection, and cute visual assets to enhance user experience. Next is our project abstract. Fluffy is a Java-based memory matching game that demonstrates the use of object-oriented programming principles and asynchronous programming. The game uses encapsulation, inheritance, abstraction, and polymorphism to organize game logic and UI components. Java swing timers are used to handle real-time updates such as the game timer, card flip animation, and delayed card comparison. Next, for our project's demonstration, which will be led by Maria May Wagas, we will show the pre-recorded demonstration of the game, and this demo will highlight the main menu, level selection, gameplay, and how the game responds to matched and mismatched cards.
Hello, good day, sir. I'll now give a quick demo of our game called Fluffy, a memory match game. So, in our game, we were aiming for a cute and fluffy theme. So, please follow along the screen while I demonstrate the main features. Let's start with clicking the Start button, which is at the center. At the top, you can see the timer label showing time, which updates every second. I'll click on any covered card. When we do this, the card flip method is executed, which starts the flip animation timer. So, may animation mahitabo mo vertically flip siya. I'll click a second card. If two cards match, they stay face up. If not, both cards automatically flip back. And the score label decreases by 1 point. For example, that automatically flip back. And the score was deducted by 1 point. So, kung sayop, bawas gyud ang score. Now, I'll click the pause button at the top right corner. A dialog window appears, and the timer stops immediately. So, safe ra mo pause para dili siya mawala ang oras. Clicking resume closes the dialog and the timer continues from where it stopped. Dayon ra balik sa do. I'll quickly match the remaining pairs. After each successful match, all match method is called. So, once all cards are matched, the show level complete method is triggered automatically. This. So, kung limpyo na tanang cards, automatic gid siya nga mag-pop up. This dialogue has three main sections. The title, which says level 1 complete. The final score, which is 9. And the total time elapsed, which is 1 minute and 42 seconds. So, final na gid ni nga stats, dili na mausab. I'll click the next level, which is enabled for level 1 to 9. The dialog closes, and the level 2 loads instantly using the same UI components but with larger grid. Mas lisod na gamay kay mas daghan cards. Naada og 2. From the pause menu, I'll open the select level. As you can see, the colors of each level are pastel palettes. You'll notice that level 10 is grayed out and labeled coming soon. This button is disabled using set enabled false, which means dili pa siya playable. To return to the main menu, I'll just click this button here, which demonstrates the navigation of the game. That completes the live demo. As you saw, we use swing timers for real-time time tracking and smooth flip animation, and the overall UI logic is driven by object-oriented concepts such as inheritance, encapsulation, abstraction, and polymorphism.
Now that you have seen how the game works from a player's perspective, I'm going to explain how we applied object-oriented programming principles, starting with abstraction and encapsulation. Abstraction is implemented by defining components that hide complex logic from the user and other parts of the program. Example: the game screen class handles all gameplay logic internally. The card class hides animation and image handling detail. Here, the internal state of a card is hidden, and other classes interact with it through methods only. Next is encapsulation. It is achieved by keeping fields private, and this prevents other parts of the program from directly modifying card states, ensuring better control and fewer bugs. Next is why abstraction and encapsulation matters. These principles help keep the code organized, readable, and easy to maintain. If we change how a card flips or how a timer works, we will only modify one class without affecting the others. Now that we have covered how we protect and organize data, the next presenter will explain how inheritance and polymorphism help our game reuse code and behave dynamically.
Inheritance and polymorphism. Inheritance allows one class to acquire properties of another. In our project, we use inheritance extensively with Java Swing components. By extending JFrame, JPanel, and JButton, we reuse built-in UI functionality while adding our own behavior. Polymorphism allows the same method to behave differently depending on the object. Different components override Paint component to draw backgrounds, cards, and animations differently. Runtime polymorphism. Here, the program checks components at runtime and treat them as card objects, demonstrating dynamic method dispatch. This allows flexible behavior without hard-coding logic for each component.
Asynchronous programming and timers. Asynchronous programming is implemented using Java's timer class. This allows the game to run actions without freezing the interface. Game timer example. This updates the timer every second while allowing the player to continue playing. Delayed card comparison. This delay lets players see mismatched cards before they flip back, improving gameplay experience. Challenges and solutions. Challenges phase. Managing multiple timers, preventing multiple cards clicks at once. Synchronizing animations. Solution. Use Boolean flags like checking and flipping. Carefully started and stop timers. Encapsulated logic inside the card class. What we learned through this project, we learned how to apply OOP principles in a real application, how polymorphism amplifies complex UI behavior, and how asynchronous programming improves responsiveness. We also improve teamwork, debugging skills, and understanding of Java Swing. Thank you for watching our presentation of Fluffy. We hope you enjoyed learning about how object-oriented programming and asynchronous programming were applied in our game.